In this video, we will continue practicing our proportionality theorem, which is also known as the side splitter theorem. Problems like these to find unknowns. For problem number 1, it will be good to use the side splitter theorem because this piece right here that we're trying to find is not a triangle side. It's just a piece. So let's do the pieces. It would be good to have a number for this portion right here, and if this is 4 and the total is 14, of course that makes this 10. Now, according to the side splitter theorem, this pair will be proportional to this pair. So let's set up that proportion. So, for example, x over 15 should equal 4 over 10. And you cross multiply. I like to reduce as much as possible, so I'm going to do that. X over 15 is equal to 2/5. Now, so that's 5x is equal to 30. Divide both sides by 5. And you get x equals 6. Before we look at problem number 2, let's review how parts and wholes work. Let's say if you knew that this was length 15 and this portion was labeled as x, what expression could you put for the green part? You would put 15 minus x. Alright, it's the whole minus the part that you already have. Let's look at one more of those. This time, let's say the entire length was x, and you knew that the yellow portion was 7. What expression could you put for the missing part right here? You would put x minus 7. Again, it's the whole minus the part that you already have. That's going to be useful in problem number 2 because especially here where we have the variable, we really need an expression for this missing part right here. What would be an expression for this missing part of the overall line? Yeah, it's going to be the whole minus what you already have. So the expression here would be x minus 25. We can get an actual number for this part right here by doing 24 minus 15. That's going to be 9. So there are two different ways to do this problem. One way is to do the side splitter theorem, and so we could know that these two, this pair is going to be proportional to this pair. So let's follow through and see how it would work out that way. So we could do, for example, x minus 25 over 25, and that should equal 9 over 15. Now I like to reduce these. Both of these are divisible by 3. So that'll give me x minus 25 over 25 equals 3/5. So then I could cross multiply. When I multiply the 5 times the x minus 25, don't forget to distribute. In fact, let me show this extra step. We're doing 5 times x minus 25. Of course, 3 times 25 is 75. But you have to do the distributive property, so that'll be 5x minus 125. And then we would add 125 to both sides. So that's going to give us 200. And then if we divide by 5 on both sides, that's going to give us 40. Number 3. All set up for the side splitter theorem once again. These two should be proportional to these two. So we could set that up as x over 18 should equal 20 over 8. 20 over 8, I said. I'm going to reduce these. These are both divisible by 4. So that's going to give me 5 over 2. Cross multiply, that'll be 2x equals whatever 5 times 18 is. Okay, that's 90. And then if you divide both sides by 2, you get 45. Alright, number 4, let's keep using the side splitter theorem, especially since we need this piece right here. But we'll need this portion right here. If the total is 12 and that's 2, of course this is 10. So by the side splitter theorem, this pair should be proportional to this pair. So as we set that up, that's going to be x over 15 is equal to 2 over 10. I like to reduce. These are divisible by 2, so that'll be 1/5. So that'll be 5x is equal to 15. So if you divide both sides by 5, we will get x equals 3. I'm not going to use the side splitter theorem on this one. On this one, everything we have labeled represents full sides of a triangle. Alright, because understand we have the small triangle on the inside, and then we have the outer triangle. This 5x is the side of the small triangle. And then of course the 45 is the corresponding side of the large triangle. This 20 is the side of the small triangle, and this 36 is the corresponding side of the large triangle. So we can just use our traditional corresponding sides of similar triangles to do this problem. Okay, so the 5x and the 45, which are corresponding sides, should be proportional to the 20 and the 36. Alright, we wouldn't, it would be more difficult to use the side splitter theorem. So setting these up, alright, these are proportional. So 5x over 45 should equal 20 over 36. Okay, let's reduce these. They're both divisible by 4. Alright, if you're not good at that, then you could do 20 over 36. But I definitely recommend reducing. So that's 5 over 9 over there. Alright, so I got the x there. I would reduce these two. 5 over 45. 5 goes into 45 9 times. Okay, so cross multiply, but I think you can see this x is going to turn out to be 5, right? But anyway, if you cross multiply, that's 9x, and 9 times 5 is 45. And then you divide by 9 on both sides, and that's going to give you x equals 5. Alright, I would go back to using the side splitter theorem for number 6, but we'll need this piece. It's easy. If the whole is 28 and this portion is 8, then this part must be 20. Now the split sides should be proportional to each other. So this pair of sides should be proportional to this pair of sides. So if you set that up, it will be like 3x minus 5 over 10 should equal 20 over 8. Alright, 20 over 8 is 5 halves. Alright, of course you'll get the same answer if you don't reduce, but working with smaller numbers is easier. So as I cross multiply, I'm doing 2 times the 3x minus 5. Don't forget to distribute. And 10 times 5 is 50. So distributing, I'll have 6x minus 10 equals 50. And then I am adding 10 to both sides. Okay, I don't want to get into the other problem, so I think I'll bring it up. So that'll give me 6x is equal to 60. So if I divide by 6 on both sides, I'm going to get x equals 10. Alright, this problem is all about the side splitter theorem. It doesn't have to be a triangle for these pairs to be proportional. Yeah, let me call this x. So this pair of parts should be proportional to this pair of parts. This is only true because these lines are parallel. At any rate, we could set up the proportion by doing, for example, 15 over 6 is equal to 25 over x. These are both divisible by 3. Alright, that's 5 halves. So if you cross multiply, I'm going to get 5x equals 50. And then if I divide both sides by 5, I'm going to get x equals 10. Okay. Alright, let's look at number 8. Okay. Alright, number 8 requires a new little piece of mental technology. So let's go to the black screen. Remember, we were practicing working with parts, but now they're hitting us with something that we never practiced. So let's come back here again. So let's say if we knew that this whole length was 10. What we said before was if this part was x, then this part would be 10 minus x. Okay? But here's the thing that's new. What if all I told you was that this was 10? And I needed an expression for both parts. I didn't give you anything. So the only difference is you have to make up your own variables. Okay? So you will come in yourself and say, okay, let's say this is n, and this would be 10 minus n. You just have to make up your own variables. Okay? So let's do that one more time. Say if I told you that this whole thing was 17, and that's it. Give me an expression for the yellow and the green. Well, you got to make up your own, whatever you want for the yellow. I'm going to use B. But if the yellow is B, then now the green will be 17 minus b. Okay, back to the problem. So here we're supposed to find this. So let's go ahead and call that x. But if this is x, what would be an expression for the other portion? Looking at the whole, this is going to be 77 minus x. So now, according to the side splitter theorem, this pair should be proportional to this pair. So that means x over 77 minus x should equal 30 over 25. These are divisible by 5. That's 6/5. So now we cross multiply. So this is going to be 5x is equal to 6 times 77 minus x. And we distribute. So that's going to be 5x equals 462 minus 6x. When you have a variable on both sides, the first thing you want to do is get those together, in this case by adding 6 to both sides. Okay, so that's going to give me 11x is equal to 462. So then we would divide both sides by 11. Okay, we already have the 462, so I can just go divide it by 11, and that's 42. Okay, so that was number 8. Alright, that's the end of the first page, so that's a good place for me to stop this video. There's more to come. I'll give you a sneak peek on the next video. It looks like mostly more of the same. Okay. Oh, okay. We're getting into angle bisectors, so that'll be something new on the next video. I'll see you on the next video.